Imagine a future where humanity has expanded its horizons beyond Earth, transforming barren planets into thriving ecosystems. This ambitious dream is known as terraforming, the process of altering a planet's environment to make it habitable for Earth-like life. But what does it truly mean to terraform? And what potential does it hold for our future among the stars? Join us as we explore the science, challenges, and possibilities of terraforming distant worlds. To understand terraforming, we must first examine the candidates for this transformative process. Mars, with its cold, thin atmosphere and surface conditions hostile to life, is often considered the prime candidate for terraforming. It has water ice at its poles and evidence of ancient rivers and lakes, hinting at a more hospitable past when conditions may have been more akin to those on Earth. On the other hand, Venus presents a different and perhaps more daunting challenge: a thick atmosphere dominated by carbon dioxide and sulfuric acid clouds, with surface temperatures hot enough to melt lead. The average temperature on Venus is around 900 degrees Fahrenheit, and the atmospheric pressure is about 92 times that of Earth. While these characteristics make Venus seem inhospitable, its proximity to Earth and the presence of some water vapor in its atmosphere has sparked discussions about the potential for terraforming here, too. Both planets have unique characteristics that make them intriguing targets for terraforming, but they also pose significant challenges. Mars, for instance, has an atmospheric pressure less than 1% that of Earth, which means it cannot retain heat effectively. The average surface temperature hovers around -80 degrees Fahrenheit, and any water present is largely frozen. To initiate the terraforming process, we need to create a more suitable atmosphere, one that can support liquid water and a breathable environment for humans. For Mars, scientists propose several methods to thicken the atmosphere and raise temperatures. One of the most discussed strategies involves releasing greenhouse gases, such as carbon dioxide, to trap heat and warm the planet. This could be achieved through massive industrial processes or by using space-based mirrors to reflect sunlight onto the Martian surface. Imagine deploying a fleet of satellites designed to focus sunlight onto specific regions of Mars, gradually warming the planet and initiating the melting of its polar ice caps. As the ice melts, it could release trapped carbon dioxide, creating a feedback loop that further thickens the atmosphere and raises temperatures. This kind of terraforming plan, while ambitious, could take centuries or even millennia to fully realize, underscoring the scale of the challenge we face. Once the atmosphere is thickened, the next challenge is to introduce water. While Mars has water ice, it lacks stable liquid water on its surface. Melting the polar ice caps or redirecting comets and asteroids rich in water could provide the necessary resources. By creating oceans and lakes, we would not only support potential ecosystems, but also help stabilize the climate. The introduction of liquid water is crucial because it serves as the foundation for life. Earth's ecosystems are heavily dependent on water, and establishing a hydrosphere on Mars would be a monumental step toward creating a habitable environment. Moreover, the presence of liquid water would allow for a variety of geological and biological processes, potentially leading to a vibrant, self-sustaining ecosystem. Introducing life is perhaps the most fascinating aspect of terraforming. Scientists envision genetically engineered plants and microorganisms that could survive the harsh Martian conditions, helping to produce oxygen and further enrich the atmosphere. These pioneer species could establish ecosystems that would eventually support a wide variety of life forms, paving the way for human colonization. One exciting avenue of research involves the development of extremophiles, organisms that thrive in extreme environments on Earth. By studying how these organisms survive in harsh conditions, scientists can identify traits that could be used to engineer plants and microbes capable of withstanding Martian temperatures and radiation. For example, certain types of bacteria can metabolize carbon dioxide and produce oxygen as a byproduct, which could be instrumental in creating a breathable atmosphere. However, terraforming isn't without ethical dilemmas. Should we alter another planet's environment? What about potential microbial life that may already exist beneath Mars' surface? The moral implications of terraforming require careful consideration and international collaboration. Should we prioritize human colonization over the preservation of potential native life forms? As we ponder these questions, we must recognize that any terraforming effort carries the weight of responsibility. The ecosystems we create on other planets must be designed to thrive without disrupting potential native life forms, and careful protocols must be established to ensure that our actions do not lead to irreversible harm. Currently, our exploration of Mars is in its early stages. Rovers like Perseverance and Curiosity are actively studying the planet's geology and searching for signs of past life. These missions are critical not only for understanding Mars, but also for informing future terraforming efforts. The more we learn about the planet, the better equipped we will be to tackle the challenges of making it habitable. The data collected from these missions helps us build a comprehensive picture of Mars' history, geology, and climate. For instance, understanding how water once flowed on the planet can guide our efforts to reintroduce it. Additionally, analyzing the soil composition will help us determine which nutrients are present or lacking, enabling us to develop suitable agricultural practices for future colonists. Moreover, insights gained from studying Mars can also benefit our understanding of Earth. By investigating how different planetary environments evolve, we can better appreciate the delicate balance that sustains life on our own planet. Furthermore, as we push the boundaries of exploration, technology plays a pivotal role in our efforts. Innovations in robotics, artificial intelligence, and biotechnology will be crucial for successful terraforming. Imagine autonomous drones equipped with sensors and tools capable of planting vegetation, analyzing soil, and managing local ecosystems on Mars. NASA, along with private companies, is exploring various technologies that could aid in terraforming. From advanced robotics to artificial intelligence, innovations in science and engineering will play a crucial role in this endeavor. The creation of artificial ecosystems, complete with temperature regulation and nutrient cycling, could provide a foundation for sustaining human life on Mars. Collaborations between governments, universities, and private sectors will be essential in pooling resources and knowledge for successful terraforming projects. The rise of space entrepreneurship has opened up new avenues for innovation, fostering a spirit of collaboration that could accelerate our progress in planetary engineering. Programs like SpaceX's ambitions for colonizing Mars not only aim to establish a human presence, but also encourage discussions about the long-term viability of such initiatives, including terraforming. The goal is to create a self-sustaining city on Mars, which would require significant advancements in terraforming technologies and strategies. Imagine a future where humans walk on the surface of a transformed Mars, surrounded by lush greenery, flowing rivers, and a vibrant atmosphere filled with clouds. The challenges of climate, atmosphere, and life would have been overcome, creating a new home for humanity. But terraforming is not just about creating a new Earth. It's about understanding our place in the universe and our responsibility to preserve and protect the ecosystems we already inhabit. As we look to the stars, we must balance our ambitions with a commitment to sustainability. The knowledge we gain from terraforming other planets could also inform conservation efforts on Earth. By studying how to create and maintain habitable environments elsewhere, we could develop new strategies for preserving our own planet's delicate ecosystems. This knowledge could prove invaluable in addressing challenges like climate change and biodiversity loss on Earth. The potential of terraforming invites us to dream big and expand our horizons beyond our home planet. As we continue to push the boundaries of exploration and innovation, the idea of making other worlds habitable becomes more tangible. However, it is essential that we approach this endeavor with humility and respect for the cosmos. Each step we take towards terraforming will shape not only the landscapes of other worlds, but also our understanding of life and our role within the universe. As we stand on the precipice of a new era of exploration and discovery, the questions loom large. What lies ahead for humanity among the stars? Will we succeed in turning these distant worlds into homes for future generations? Only time will tell, but the journey to make our cosmic dreams a reality has only just begun.